Hello everyone, welcome to SIG Autoscaling weekly meeting for Monday the 25th March 2024. We have a few items on the agenda already. Just on the first, on test grid, still got two flaky, two failing on the cluster autoscaler. Couple of flaky on HPA, one flaky on VPA. Carpenter is all green at the moment. I'm not sure if anyone's managed to have a dig yet into, I don't think so, into the current CA ones, which are the priority. I'll see if we can find anyone able to do that this week. Jeff is, I don't think is here. No, I'll chase them up on Slack again. Krishna.
Hey. So this is in regards to, hey, good morning all. Hope you all had a nice weekend. This is in regards to the feedback on unsafe termination of a placeholder node. So this is the issue, it's coming back to us on our production environment where the cluster, especially the 4489, introduced the placeholder nodes and early termination of the placeholder node, if there is any insufficient capacity error. And in our case, we are running into insufficient capacity error for the first time, but subsequently ASG is able to provision the node. And coming back through the iterations, cluster autoscaler terminating randomly one of the node from ASG, which happened to be hosting production workloads. So that's causing the problem. So I was looking for a feedback or basically implementing the logic for avoiding unsafe termination. Basically identifying the node that was most recently provisioned or any other mechanism to honor the node rather than terminating it, right? Because it succeeded anyway in subsequent operation, perhaps rather than terminating it. Maybe it can honor the provisioning the node and adjust the autoscaling capacity accordingly.
Yeah, it feels like this is entirely AWS specific rather than the core autoscaler.
Can you? Sorry, I didn't fully understand. Like, what happens in AWS specifically? Because I agree that shouldn't happen sort of in general in cluster autoscaler, but I didn't understand the full details.
Basically, right, we try to scale up. Cluster autoscaler basically tries to scale up by setting the desired capacity, right? And ASG on the other hand goes and tries to provision, and in the first iteration it fails with insufficient capacity in one of the availability zone, for example. But eventually it succeeds, in a couple of 1 or 2 seconds, it's going to succeed in the next AZ or within the same AZ if the capacity becomes available, right? That's where the race condition is. And what's happening was, cluster autoscaler describing the scaling activity, thinking that, oh, you know what, there is an insufficient capacity error, and it goes and set the desired capacity back to what it was before, like, basically the desired capacity minus failed number of nodes in a nutshell, right? And that's resulting in a random node termination, which happened to be hosting stateful workloads in our case.
Are you only seeing this in multi-AZ ASGs, or have you seen this in cycling?
Yeah, multi-AZ. But the thing is that it can happen in single AZ as well, right? So, I mean, it is an iterative process, right, in a ASG. So, I mean, there is a disconnect between what ASG is doing and what cluster autoscaler is doing. It's not seamless, it appears to be based on my observation.
I think if the scale-up phase normally cluster autoscaler picks a specific, like it tries to delete the, or at least the core logic is designed to try to delete the specific instance that didn't provision successfully. But I guess that relies on the whole placeholder. There's this placeholder VM while it's spinning up, and I guess good placeholder to instance mapping in provider.
Absolutely. See, the instance mapping, perhaps there is a disconnect, what I see. So it is trying to see the placeholder and it's trying to, actually, it is clearly documented in 5829 and 5846 threads. So it is seeing that, oh, there is a placeholder instance. Let me go and terminate that placeholder instance. But there is no connection between the instance provisioned by ASG and the placeholder, and then the cluster autoscaler simply setting the desired capacity to terminate, to reduce the number of, provision nodes, right? So that's resulting in, random node termination rather than terminating the node by instance ID.
Yeah, my gut feel is that 5846 is probably not the right way to solve this, and we should actually instead have some better sense checking before we perform that deletion of actually has an instance since come up, and make sure that either if we are still going to delete, we're deleting that node, or if not, or potentially not scaling down. So I think it feels to me like 5846 is likely to result in us ending up in a place where we probably have more capacity than we would ideally want. And obviously, like, eventually that should be resolved. But yeah, I'm slightly worried about side effects of that one.
Yes, Guy. I mean, one way to solve the problem is mapping the node that was provisioned by ASG to a placeholder node and terminating the most recently provisioned node, right? That's one way to solve the problem. But again, right, what I'm thinking of is the node is provisioned successfully anyway. So rather than terminating it, right, perhaps we can look into reconciling that into cluster autoscaler, right? It knows, right, because this is a result because of partially affected nodes. So why not reconcile that into existing ASG, right? Existing cluster autoscaler configuration rather than terminating it.
That feels like something that should be doable entirely inside AWS provider, because I think cluster autoscaler already should support it, because the interface to cloud provider integration allows you to essentially return what instances. Like the expectation of core logic is that those placeholders are basically AWS implementation, but the expectation is you really are returning a list of VMs in error state. Now, because as I understand, ASG doesn't provide that in easy to consume way, there is this placeholder logic, but that's very much artifact of AWS implementation. And it should be possible in principle, as long as internally there is good mapping of placeholder to actual VMs. But I don't know how easy that is to implement.
Yeah, I mean, shouldn't the AWS provider know that if it has started a scaling operation, fails, and reports that back to the core, but then it ends up succeeding by creating this placeholder node, on the next time it's asked to do something, doesn't the AWS provider know that it's got like a different replica count and it has an extra, or it has some extra amount of these like placeholder nodes? Doesn't it know that those are there? Like, couldn't it figure out how it got there and then know to delete the placeholder node? I guess that's what I'm wondering.
That's sort of what so what it's doing at the moment is effectively if placeholder nodes are stuck there for too long, it scales down, and because and this is where the sort of issue comes in, because placeholder nodes don't actually map to a specific node, it instead scales down the desired count of the SG without the usual logic of like saying I want this specific instance gone, because in a case where it assumes that it's not actually provisioned a new instance, then it will like take the option of going, okay, I'm decreasing the desired count because the running count is just to the current running count. So actually, I think we should just be able to include some safeguarding logic there. I would need to take another look at that sort of area of the code again, but I think we should I agree with Maciek. I think this is entirely doable. With like this is purely a concern for the AWS cloud provider. It's not touching anywhere else, I don't think. I will see if I can give that a look and just figure it out. If so, I'll put in some feedback on 5829 and 5846. Cool. Anything more on that from anyone?
Thank you, guys. So you're going to take a look at the code and provide us the feedback, right? Yeah. Thank you very much for your help.
Yeah. John. Hacking / implementation.
Yeah. So, okay, so it's like 6 months ago, I was like, hey, is anyone working on in-place VPA? And you guys are like, no, go ahead and knock yourself out. So I finally got some time last few weeks to try it. And it's still very like, it's work in progressy. So don't like, I don't expect anyone to spend for time doing a bunch of review or anything, but it was just kind of like, well, let's see if we can get it in there and see kind of what it does and how it works and if it's useful to anybody. And the short version is like, well, if you have limits on your containers, it totally works. But if you don't, bad stuff happens. Like basically you'll just kind of like sit there for like hours and be like, oh yeah, I'm totally resizing that. And it doesn't. So I don't know a bunch about like the internal mechanisms it does under the hood. And it's not like a super verbose feature, right? Like it's not like you do it and the cube is like, oh yeah, hang on, let me go get some resources for that. And I'm going to sit and wait. And like, you know what you're waiting on. It just kind of like doesn't do anything. So I don't know. I haven't dug into it a bunch. And some of this was like reverse engineering sort of, work, and I'm kind of like learning while I'm doing it. So don't be like, John thinks this is great. Yeah, no, it's iffy, but at least I feel like I know something where it's like, well, if we were to implement this today, I feel like it'd be kind of if you don't have limits, you're gonna be waiting for a while for your resources, and that makes it like maybe not super compelling. So I don't know. I'm just letting you know, like, I don't want to work in a vacuum, but like I was, hey, let's kind of put this up and see, kind of where it goes. So I don't know. I feel like next step for me is probably, hey, look into how that upstream feature works and see where I might getting snagged when I have limits. But I guess if there's like feedback, if it's a no, we already know that and it's hard, or it's or it's we don't know that, and cool, go ahead. I don't know. I just kind of wondering what folks thought.
I mean, I'm very excited to see an implementation. Even like with all those provisos in place, like I'm interested to see something that people can start having a dig around. I guess Maciek, who might be best placed to give it a look on Google side?
Probably Kuba, but yeah, there is probably a lot of knowledge that may be missing, right, and some context. So we can have a discussion, but we need to work together.
Cool. Yeah. And that's not like I'm not hurried. It's like, oh my gosh, it was just I'll kind of keep clicking away and clean it up. I think there's a couple of tests I broke too. I don't have a bunch of tests for the suite or anything, so it's not like it's like there's nothing else to do. It's just I mean, at the very least, like the tests would be valid regardless of implementation. So thanks.
Thanks very much. There's some other people I was talking to about this at KubeCon who will be interested in seeing like at least this first implementation. So I'll ping them as well and see if we can get some other eyes on it. thanks very much.
Yeah. Thank you.
I guess next one we've got to be I don't think we have, yeah, to be discussed after 25th, so probably next week. However, if people want to have a look at those issues already, basically discussion around aligning some of the core Carpenter and cluster autoscaler concept, naming and workload level APIs. This was something that was sort of mentioned at the SIG Autoscaling update at KubeCon. But yeah, if people have any existing thoughts on those, please feel free to weigh in, and we'll discuss in more depth next SIG call. That's it for the current agenda. Does anyone else have anything they want to raise?
Hi, good morning, everyone. So I raised a PR request 2 weeks ago about so the VPA when running with a lot of pods and it consume a lot of memory, and the PR is it's basically on the matrix client that potentially can save memory by not ignore the pod that don't have the VPA config. Don't know whether the reviewers have a chance to take a look.
That's 6583, right?
The PR number, yes, give me 1 second. Opening. Yeah, 6583.
Sorry. If we got us. I'm not sure if any of them have had a chance yet. It doesn't look like anyone's had a look yet. The other person it might be worth getting a review or asking for a review from is Marco. I'll ping him in on the PR.
Okay, yeah, it's in no rush, but it's really hoping to get some feedback so that.
Yeah. It doesn't. It's not a. It doesn't look like it should be a massively time-consuming one. So. Okay, cool. Thanks for raising. Anything else from anyone else? Arno, since I see you've joined us. Anything in particular?
You want to talk about the okay. So hi folks. I met with some SIG Autoscaling folks during KubeCon, and we were talking about an implementation of Carpenter for GCP. So I'm curious about the process of how we can do that and have the code base also implements the SIG organization.
Go on, Elmico.
Yeah, so hi Arno. I'm in the process of leading an effort to build a cluster API provider for Carpenter right now. And so basically it started with looking at the Carpenter framework and library that are in Kubernetes SIGs. And then I've been going to the Carpenter working group meetings. But basically I started by looking at that code. You can look at, there's a Carpenter provider AWS and a Carpenter provider Azure. Those are also good references. But what you probably want to do is start by looking at that framework code. And then you'll want to start a new repository that you'll call like Carpenter provider GCP or something. And you'll include that Carpenter library as a dependency, and then you'll build your code from that. So if you look inside the core Carpenter repository, there is a Quack provider, which is used as like a testing provider. That's very, very simple, but it'll give you an idea of how things are structured. And then you could look at the AWS provider and the Azure providers to see how they kind of build a more complicated provider implementation. But really, it's going to come down to there's a cloud provider interface, very similar to what the cluster autoscaler has. And so you'll be doing a lot of work kind of satisfying that cloud provider interface. I guess if you have specific questions, I could get into some of that. But I think in general, this is where you'll want to start. And then, if at some point, if it becomes, if you want to, you can contribute it to the Kubernetes SIGs organization, once you have everything set up and whatnot, if that's what you want to do. I guess, does that answer your question, Zarno?
Yeah, that give me guidance on the implementation, but I think my other question would be how we define ownership if I basically request a new repo for that implementation. Is like,
so
yeah,
that would be like proposing. There's a Contribex has an issue you can open in, I think, the Kubernetes/org repo, and you request a new repository there, and then you would put the owners, in it, and so like that is where the ownership and everything would be kind of, worked out. I think you might want to start by creating like a private or creating like a personal repository for this work, gathering some collaborators that you want to work on it with you and kind of setting things up. And then you can actually donate the whole repository, and you would already have like the owners in place and everything. So I think if you're concerned about getting the proper kind of people in place to start with, I might take it from that direction.
Okay. I think I would try. I come from the KOps project because there was currently KOps ship Carpenter for any new KOps cluster.
Wow, that's cool.
I was talking to Justin and Cyprian about how we want to also do that for JCP because there's a long roadmap around KOps. So the question will be how we want to have an opinion implementation of Carpenter for GCP and basically make sure we can also add that to KOps.
I would say just start it in a personal repo, and when you get to a point where you feel like you're ready to accelerate collaboration or whatever, that's a great time to look at contributing it to Kubernetes SIGs at that point. I'll shut up so Magic can get in here.
Yeah, I have nothing to add on the core issue of the question. Just on purely technical side, I wanted to give you a short heads up that I think for a self-managed GCE cluster, there is no particular reason why you couldn't implement Carpenter, but it's going to be very hard to make it work for GKE because in GKE you cannot join a VM to a GKE cluster without going to the GKE node pool API. So just a heads up that technically it may not be very easy to integrate it with GKE. I don't know if, since you're working on KOps, I don't know if that's something that interests you anyway. Just wanted to get it out there.
Yeah, we don't target GKE cluster currently.
Yeah. In that case, I think there isn't really any technical problem I'm aware of.
Okay.
Awesome. I guess my immediate thought, sort of longer term, when we're looking at donating, is where those ownerships would likely fall if we start donating those repos, sort of community maintained, for want of a better word, or even the existing ones, to live under Kubernetes SIGs, whether they become almost even more sub projects or sub projects somehow, since obviously with them being effectively implementations of Carpenter, they become heavily dependent on what changes happen in that core. So maybe that's something well, it is something we're probably better starting off thinking about now, maybe discussing at a Carpenter working group or sort of meeting sooner rather than later.
Yeah, definite +1 to taking it to a carpenter meeting. Like when I started working on the cluster API provider, I took it to the cluster API meeting. I took it to the carpenter meeting. You know, I took it kind of. Yeah, I brought it here as well. Like so, Arno, I think you're doing exactly the right stuff. And yeah, then the next step, like I think for the cluster API one, we're basically like a sub project of 3 different places. You know, because it's like a sub project cluster API, sub project carpenter. And I guess, yeah, sub project of SIG Autoscaling. So yeah, it could get complicated.
Awesome. Well, I think I should make a note to turn up to the next carpenter meeting and can start that discussion as soon as possible. But sweet. We are at time, so I think we'd covered everything. Everything that had at least originally been added to the agenda anyway. So thanks very much for attending, everyone, and hopefully see you all next week.
Thanks, Guy.